Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence from each one of you regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat. The agenda behind today's video is nothing. We would be taking the series of the engineering mathematics, and within the series of the engineering mathematics, I have been discussing about the vector calculus, and within the vector calculus, this session is dedicated for this lecture number 7. If you guys would be able to recall, in last video I was discussing about the cylindrical coordinate system, and almost the cylindrical coordinate system got over in the last video. So in today's video, basically I would be discussing about the different important concepts within the spherical coordinate system. That means what are the different numbers are there within the spherical coordinate system, what are the different numbers are there within the spherical coordinate system, what their actual significance is, what does that mean by r, what does that mean by theta, what does that mean by phi, and similarly what are their ranges. If we will talk about the r, from where to where the r can range, similarly the range of theta, similarly the range of phi. And as we have been discussing in the last video, the differential length, differential displacement, differential area with the unit normal, and the differential volume are the 5 important factors within the any coordinate system. So obviously I would be discussing about those factors also, and end of the day I would be discussing about the unit vectors in the direction of r, that is a r cap, theta, a theta cap, and similarly in the direction of a phi cap. Because I have seen most of the time the student do have the physical understanding of the ax cap, ay cap, and az cap, but once they come into the cylindrical or the spherical coordinate system, they do not exactly have the idea about their unit vectors in the direction of ar cap, a theta cap, and a phi cap. That is why what happens, specifically the student from the electrical as well as instrumentation, they had to go through the electrostatic as well as magnetostatics within their electromagnetic field theory, and once they deal with the Gauss theorem and at the same time Ampere's theorem, they used to trap themselves because they do not have exact understanding about the different unit vectors in the direction of ar cap, a theta cap, a phi cap, a rho cap, a phi cap, az cap. Agreed what I am saying? So end of the day you will have the fair idea about the unit normals which has been involved over the spherical coordinate system. So without getting delayed, let me straight away jump into the working board. So as it has been clearly communicated earlier, the agenda behind today's video, I would be focusing over the spherical coordinate system. So the heading of the today's video is simply going to be spherical coordinate system. Spherical coordinate system. Now at very beginning I would be writing few of the important theoretical aspects regarding the spherical coordinate system. The first point goes like, what are the 3 different numbers are getting involved for unique identification of a point over a 3D space. In case of Cartesian coordinate system we had the x, y, z. In case of cylindrical coordinate system we have rho, phi, and z. And now in case of spherical coordinate system we would be having the 3 numbers, and they are nothing but r, theta, and phi, and their sequence are very important as we have seen earlier, because in sequence the cross multiplication would be valid. That's the first important thing. Once we are done with this, I would be discussing about the range of the value of r as well as theta as well as phi. So the value of r would always be a positive value, because r is nothing but the radius of a sphere, and the radius of the sphere cannot be negative. So the first range goes like, the value of r could be anything in between 0 to infinity. Anyways, infinity is a non-achievable number, so usually we used to exclude the infinity. That means r could be anything in between 0 to infinity, including 0. Similarly, if we will talk about the range of theta, here comes the range of theta. The theta has the range in between 0 to pi. Many of the students do have one doubt, sir, why don't the theta goes from 0 to 2 pi as the phi had? No, the theta would go from 0 to pi, and we will see why the theta has the range from 0 to pi alone. Once we are done with this, we would be discussing about the phi. My dear friends, the phi is the same phi which we have discussed in case of cylindrical coordinate system, and once we will be talking about its limit, the limit was starting from 0 and was going till 2 pi. So the phi is the same phi which we have seen earlier. So it goes from 0 and goes till 2 pi. Yes. Now the next thing comes in the picture. See what I have done. In case of cylindrical coordinate system, I have taken in background the Cartesian coordinate system, and over the Cartesian coordinate system I have taken a point over a 3D space, and I tried to connect the x, y, z with rho phi z. Now the same process I would be following. What I would be doing at background, I would be taking the Cartesian coordinate system where we would be having the three values which are nothing but the x, y, z, and now I would try to relate the x, y, z with the three numbers over the spherical coordinate system, and that's nothing but the r theta phi. And as it has been communicated earlier, what does it mean of it? What has been communicated earlier? It has been clearly communicated. All of the coordinate systems are interchangeable. That means at any moment of time, any of the vector quantity which is written in the Cartesian coordinate system can be brought it to the spherical, or from spherical to cylindrical, or from cylindrical to Cartesian, or vice versa. So definitely I can take a situation, just a minute, I can take a situation where at background I have taken the Cartesian coordinate system. How many axes you will be having? 3 axes you will be having. In the right hand side you will be having the positive y axis, towards upside you will be having positive z axis, and towards vertically outside you will be having positive x axis, yes. So here I would be writing all of them, just a minute. So here goes the positive z axis, here goes the positive y axis, and here goes the positive, just a minute, let me change a bit, and here goes the positive x axis. Yes, so at background I have taken the reference of Cartesian coordinate systems which have got the three different axes. Anyways, if you guys would be able to recall why the coordinate system are being used, the basic requirement of the coordinate system is to uniquely locate a point over a 3D space. Let's take we had a point over a 3D space, over the 2D plane I am writing somewhere here. Let's take, this is the point which has to be identified uniquely over the coordinate system. Yes, in Cartesian coordinate system you had to provide the three different numbers. What are they? The numbers used to be x, which is nothing but the displacement towards the direction of x, and similarly y is the displacement towards the direction of y, and similarly z is nothing but the displacement towards the z. So here is going to be x, y and z. But as the title itself indicates a lot, now we had to uniquely locate this point, but the number which we had to take for the reference is going to be r theta phi instead the xyz. So obviously now the xyz should be able to convert it, or should that be converted in the form of r theta phi. So what I would be doing, now even I will involve, my dear friends, understand in this way. This was a Cartesian coordinate system. I would involve the cylindrical coordinate system, and end of the day I will also involve a spherical coordinate system, so that lump sum you will have a fair connectivity between all of the coordinate system. All coordinate systems are interchangeable at any moment of time. Any of the vector quantity, any of the point over a 3D space can be brought from one to another. Agreed? So what I would be doing over here, my dear friends, as I have been doing earlier, what I was doing, I was just making a footprint over z is equals to a 0 plane. Sometimes the people call it xy plane, but the z is equals to 0 plane is a better nomenclature. And once this point gets dropped over the z is equals to 0 plane, just a minute, we drops over the z is equals to 0 plane. Now what I would do, now I would take the vertical distance of this point from the x axis, and similarly I would be taking the vertical distance from the y axis. The displacement from the y axis, displacement is the minimum distance, displacement from the y axis would be the worth of x, and similarly displacement from the x axis would be the worth of y. So now I am going to calculate that. Let me change the color a bit. So here goes the displacement in the direction of x, and let me take once again the another color. So here goes this, yes, sort of this. Now probably nobody should have any doubt here. What's going to be this displacement in the direction of y. So obviously the variation or the distance from y is equals to 0 plane till this point is nothing but the worth of y itself, So here goes the value of y now. This is nothing but y, this is nothing but x, and from the point from where it has been dropped towards z is equals to 0 plane, or I can say the normal distance of this point from a z is equals to 0 plane is nothing but the worth of z itself, yes. So uniquely, if you had to identify this point over the 3D coordinate system, over the Cartesian system, so definitely what you had to do, first you had to drop this point over the z is equals to 0 plane. Now you will measure from how much height it has been dropped over the z is equals to 0 plane, and that is nothing but the worth of z. Now what you would do, now you will take a vertical distance of this point from the x axis, and that distance is nothing but y. Similarly, you will be taking the vertical distance of this point from the y axis, and that would be the worth of x. That is known to me. That is known to me. Yes. Now, what was the methodology when I was dealing with the cylindrical coordinate system? What I did, rather taking in terms of x and y, what I did, I dropped this point. The point was dropped over the z is equals to 0 plane, and once it was dropped over the z is equals to 0 plane, I just drew a line which was straight away connecting origin to the point, and this distance was written as rho. This distance was written as rho. Anyways, this distance was written as rho. Yes, this distance was written as rho. But for uniquely identifying this number, even I also had to take the reference of this angle, which was taken as phi. Yes. So within the same coordinate system, you can find the Cartesian as well as cylindrical coordinate system. Because the cylindrical coordinate system used to have 3 numbers. What are they? They used to have rho, they used to have phi, they used to have z. Agreed, no? They used to have z. Once we are done with this, see, once we are done with this, now what I would do, I would superimpose the concept of spherical coordinate system. See, what is the basic differences you will be getting, my dear friends. In case of spherical coordinate system, no, rather dropping this point over the z plane, straight away I measure the distance of this point radially from the center or from the origin. So what I would be doing, few of the changes or few of the new things are going to happen with the spherical coordinate system is simply I would be measuring this distance, yes, and this distance has been named as, small r. This distance has been named as smaller. Now with a small r, I have got one problem. Uniquely, you may not be able to locate this point. So for uniquely locating this point, still I need to get a reference of an angle, and now the angle has been taken, the reference of z axis, and this angle has been set to be theta. This angle has to be set to be theta. Yes. So again, all of the 3 component of the spherical coordinate system is in front of you. What are they? They were r, theta as well as phi. Now what I would do, my dear friends, see, this was rho. So in parallel with rho, I have taken another straight line which has been connected to z. Obviously, the length of this chord or length of this contour would also be z. You can see this and this in parallel, and it has been bounded by the same straight curves. So obviously, this is also going to be rho. Many of the times I have seen, whenever we deal with the spherical coordinate system, many of the angles are not well aware to us. But yes, this is a right angle triangle, although it may not be looking as a right angle triangle. Once you will see, probably you will find this angle as an acute angle, but it is a right angle triangle. Yes, it is a right angle triangle. What I would do, my dear friends, if you will recall, the relationship between the Cartesian and cylindrical coordinate system was very well known to me, x, y and z. Yes, the z was the same z which was used in the cylindrical as well as Cartesian coordinate system. So there were no difference as such. Once if you will talk about the value of x, the value of x was rho cos phi, yes, cos phi, and here the y was rho sin phi. Anyways, this was the number over the Cartesian coordinate system, and this was the number based on cylindrical coordinate system. If you really wants to change the spherical coordinate system into the Cartesian coordinate system, my dear friend, the cylindrical coordinate system also contains phi. So even I need not to worry about the phi and all, but yes, the rho has to get smashed from here. Could you understand what I am saying? My basic agenda is to change the spherical coordinate number into the Cartesian coordinate number. So if you will recall, what are the different relationships we have derived in the last video when I was deriving the cylindrical coordinate number into the Cartesian coordinate number. The x was equals to of rho cos phi, y was equals to of rho sin phi, the z was very same as z. Now if I would change the value a bit such that it would have the involvement of only r, theta and phi put together, whatever the expression you get now, with the help of that you would be able to convert any of these spherical number into its corresponding value of x, in corresponding value of y, in corresponding value of z. Why I am taking the help of this expression which has been already used in the cylindrical coordinate system? Because the phi is the same phi which has been used in the cylindrical coordinate system. Yes. So what I would be doing, cos phi would be kept as it is. Now we can take a right angle triangle. Which right angle triangle I can select? This is gonna be the right angle triangle, and the arm front of right angle triangle always used to be hypotenuse. So definitely R is gonna be hypotenuse, and rho, as it is coming in front of theta, is gonna be perpendicular. Perpendicular. Yes. So tell me, what would be the relationship? What would be the relationship? Just a minute, just a minute. Sound is coming from outside. So just try to get the relationship. So now I can take the reference of this right angle triangle, and definitely I can use a trigonometric ratio. What it is? Sine of theta would be equals to perpendicular, which is rho, divided by a hypotenuse, which is equals to of r, which is equals to of r. So easily I would be able to get the value of rho, which would be equals to of r of sine theta. So that means, with the help of the relationship between the Cartesian coordinate number to the cylindrical coordinate number, cos phi would remain as it is, where the rho can be written as r sine theta cos phi. Not only that, even you wanted to convert rho sine phi in a form of y, the rho has to be replaced, and now the rho can be simply replaced to be in a form of r sine theta sine pi. So just we have left out with the z, even the z can be converted in the form of r theta phi. How? See, so far my dear friends, so far I have taken sine of theta. That is why the perpendicular as well as the hypotenuse got connected within the same expression. Rather taking sine of theta, if you take the cosine of theta, so the ratio would be in between base as well as hypotenuse. May I know what it is? What it is? This is nothing but z, no? Probably you guys are able to understand it or not, but this is the height of this point from z is equals to 0 plane. So you may not be able to actually visualize, but still this point and this point, they have been kept over a same elevation, and hence here if the value is z, here also the value is z only. So let me do one thing. So here goes z. So this value is nothing but z. So easily what you would be able to do, you would be applying the cos of theta, and here it goes z divided by of r. The value of z which we get is simply going to be r of cos of theta. Here goes r of cos of theta. Could you understand what exactly I wanted to say? Agreed, no? Agreed, my dear friends? So at least this relationship can be used at any moment of time if the values of all cylindrical numbers are known. If the value of r, theta and phi is known, and now you wanted to convert that unique point into the Cartesian coordinate system, you can feed the value of theta, phi and r, you would be getting the corresponding value of x, y as well as z. That means this relationship can be used at any moment of time if you have all three spherical coordinate numbers and you wanted to convert it to the Cartesian coordinate system. So let me write it separately. So here goes x is equals to, I would recommend to each of one, you need not to by heart this exclusively. You should have a little bit relationship between the Cartesian as well as cylindrical coordinate system, and end of the day you should have a clear cut idea that the rho can be replaced with r of sine theta. Put together there were the relationship between the spherical coordinate system as well as Cartesian coordinate system has been made. So here goes x is equals to of r of sine theta, and here goes cos of phi, the y becomes r of sine theta, here it goes sine of phi, and the z is equals to of r of cos theta. Yes, here in first two outcomes the value of theta were connected with the sine, but here it have been connected with the cosine. This was the first result, and yes, it is the important result. My dear friends, so far I have not taken any practice problems or the problems from the previous year. But once I will start taking the problems from the previous year, now each and individual questions will get connected with your basics of the basic of the coordinate system. So I would expect from each one of you, the student who are continuously attending my classes, they are also maintaining a proper notes. Yes. So here goes the first outcome. Now you can have the situation when the Cartesian numbers are known to you, and with the help of that Cartesian number you wanted to get the three distinct numbers which we use in the spherical coordinate system, and they are nothing but r, theta and phi. So what I would be doing over here, let's do one thing. Let's take the square of the first equation, second equation and third equation and add them together. Once you take the square of this, it becomes x square plus of y square plus of z square. That means towards the left hand side, the component which we have got it, they are the sum of x square plus y square plus z square. But the component what we get towards right hand side, they are nothing but r square sin square theta cos square phi, r square sin square theta sin square phi plus of r square of cos square theta. Keep aside each and everything, just focus over the square of the first two numbers. R square are common in both of them, you can keep aside. Even sin square theta is common in both of them, you can keep aside. The factor which has been left out is nothing but cos square phi plus of sin square phi, which is a identity within the trigonometry. The value would be always 1 irrespective of the value of phi. Put together, the result after adding their square have come to be r square into sin square theta. Once it gets added with the r square of cos square theta, again sin square theta plus of cos square theta becomes 1. The result is simply going to be r square. Agreed what I am saying? So here the result what we get, if you are interested finding the value of r with the Cartesian numbers, easily you would be able to do that. Yes. Could you agree what I am saying? The r is done. Then we shall be moving towards the theta. May I know how will you get the value of theta now? My dear friends, you can easily get the value of theta from the last expression. The theta is simply going to be cos inverse of z by r. What I am saying? Cos inverse by of z by r, where the r is already known to me, which is nothing but the root over of x square plus y square plus z square. For the sake of completion, even the theta could have been written as cos inverse within the bracket z divided by of root over of x square plus of y square plus of z square plus of z square. Yes, no? Yes. And now the phi, what is the phi? The phi is the same phi which we have been using in the cylindrical coordinate system again and again. Now you can take the ratio between the second equation and the first equation. The result what we get is simply going to be y divided by x. The r and r is common, definitely they would be knocked off. Sin theta and sin theta is common, they would be knocked off. The factor which has been left out is simply going to be 10 of phi is equals to of y by x, and phi is simply going to be 10 inverse of y by x, which we have been using in the cylindrical coordinate system so far. So I would expect till this moment of point each and everything or each and individual concepts are clear to all of us. Now we will promptly move into the next important segment, where I would be discussing about the differential displacement, differential length, differential area with the unit normal, and at the same time I would be discussing about the differential volume. And the problem do come repeatedly once we go into the practical applications of the spherical coordinate system. Specifically, if you have a charge configuration which has been spreaded along a sphere, maybe you have a dense sphere and you wanted to calculate the mass carried by the dense sphere within the mechanical. Yes, the several amount of questions or the several varieties of the questions can be framed over the spherical coordinate system. Those questions I would be taking exclusively, and once I would be taking the questions, no, I would be dealing with the questions, and I would suggest, that is why make note of all of the concepts which I have been teaching you, yes. So let me move forward. So here I would be discussing about the few of the important parameters which we have been discussing now. So what I would be doing at very beginning, again I would be taking the reference of a Cartesian coordinate system. Here goes the x-axis, which is vertically out from this plane. Here goes the positive y-axis, and here goes the positive z-axis. So let me focus over the differential volume first. Once you are done with the differential volume, the part of the differential volume would make differential surface, and the part of the differential surface would make differential length, and you would be more than acquainted with all of three components. So at very beginning, I would be focusing a bit over just a minute, differential volume. Let me draw this, just a minute. Yes. Anyways, just copy whatever I am drawing over here, because end of the day I would be explaining the each and individual things in the great detail. Yes. Draw this down over your copy. Many of us exactly may not be able to understand how this structure has been looking like, and how to draw, how the differential volume and the differential surface and the differential length have come into the picture. Yes. Write down. See what is happening over here. This was a differential volume. Probably you may not be able to visualize which differential volume I am going to discuss about. This is your differential volume. This is going to be the upper surface of your differential volume. How many surface you have? The sixth number of surface you have. This annular surface, this down surface, and you will be having a outer periphery. Yes. So here goes the first surface. Here comes the second surface. Yes. And here comes the fourth surface. Here comes the fourth surface. Yes. Third surface. Here comes the third surface. So you yourself would be able to understand how many differential surfaces are getting involved, and they are getting involved because of changes in what are the numbers that we are going to discuss now. This is the first differential surface, the surface for which the green pen has been used. Similarly, this is going to be the second surface, differential surface, for which the blue pen has been used, and similarly this is going to be the third surface or differential surface for which the pinkish color has been used. Yes, sir? See what is happening over here. Just focus over this differential surface. May I know which value is not going to change? Why I am asking this value, this thing? See, my dear friends, in differential surface, definitely there are two different numbers they are going to change. In case of Cartesian coordinate system, they were dx dy, dy dz, dx dz. Similarly, in cylindrical coordinate system, we had the change of rho as well as phi, the change between phi and z, rho as well as z. So same concept goes with the spherical coordinate system. If you wanted to make a differential surface, definitely there must be the change in two different numbers. obviously in the form of differential values because we are forming a differential surface over here. So now you yourself would be able to understand, my dear friends, over this surface the value of r is same because they have been kept with the same distance away from the origin. If you will take over this point, this point, this point, this point, everywhere the distance from the origin is very same. That means over this differential surface the value of r is constant. And as I have been talking again and again, if you know this particular number is fixed over that differential surface, you are done with that. What? If the r is fixed, that means the unit normal would by default be in the direction of AR cap. Would by default be in the direction of AR cap. Agreed? What are the two numbers would come into the picture? First number would come because of the change in theta. The second number would come because of the change in phi. So put together, the result used to be r square of sine theta. Sine theta. Here it would come as d theta d phi. D theta d phi. D theta d phi, and it is in direction of AR cap. As it is in direction of AR cap. Yes. Now the one doubt comes. Okay, sir. D theta and d phi till this moment of point each and everything was okay, but how the r square sine theta have come into the picture? My dear friends, the d phi is the same d phi which we have used in case of cylindrical coordinate system. May I know, in case of cylindrical coordinate system, the differential arc because of the change in phi, what we had rho times of d phi. Rho times of d phi. And once you will go into the last page, you yourself would be able to calculate the value of rho was equals to of r sine theta. So once you change the rho d phi completely into the spherical coordinate system, because in the spherical coordinate system there is no place of rho has to get changed into the form of r theta phi. So simply it becomes r of sine theta d phi. That means the arc length or the differential arc length because of the change in phi would always lead r sine theta d phi. Could you understand? Because I have seen many of the times the student do have the doubt over this moment of point. Sir, how the r sine theta have come into the picture? Yes. Now the next thing. Again, you would have a differential arc because of the change in theta. And obviously d theta is not a differential arc, it's a differential angle. So the magnitude has to get multiplied. So the magnitude which we multiply over here is simply going to be r. Now the next thing comes in mind, sir, why we are multiplying r alone? My dear friends, see what is happening. In future, once you will see the basic concept of theta, as theta increases now, what happens? The solid angle of cone increases. We will see that. The solid angle of the cone increases. And you yourself would be able to understand what it is. If the theta is going to change, would you be able to understand how the theta has got changed? Here theta was different. See. Here theta was different and here theta is different. Here theta is different. And this arc length which have come into the picture, this arc length which have come into the picture, that have come into the picture because of the change in theta. Because of change in theta, and you yourself would be able to understand there was the same semantic theta, or there was the same semantic change in theta over this complete surface. But here the differential contour is smaller in length and here differential contour is larger in length. Why it has happened? It has happened because the distance from the origin, which is nothing but r, was lesser, and the distance from the origin was larger. Distance from the origin was larger. That means the differential length which would come into the picture because of the variation in theta would be directly proportional to r. You can see very well here the differential length is smaller. For the same change in theta, here the differential length is larger. So you yourself would be able to understand the same concept as we have been used in case of rho d phi. Could you understand what I am saying? So how many differential lengths you will be having? One differential length because of the change in r. Anyways, that would be simply d of r. The second differential length because of the change in theta. My dear friends, if straight away I write d of theta, that is not differential length, that is nothing but the differential angle. The r is getting multiplied, and even the reasoning also have been clearly given why the r itself have come. It could have been r cos theta, it could have been r sin theta. Why I have taken r alone? You yourself would be able to understand d theta, how much differential contour or differential displacement it segregates, that solely depends on the value of r. If the value of r is larger, it would go for the more differential contour or differential length. Agreed? And the same concept goes with this. Yes, no? Yes, my dear friends, till this moment of point, each and everything must be clear. So what I am saying over here, at very beginning, let me discuss a bit about the differential length, which we have been doing in last coordinate system. Differential length. Now you would be having the differential length because of the change in r, yes, that is simply equals to of dr, because the r is a length, so obviously it would be simply dr. Next goes the change because of theta, or the differential length because of the change in theta, so simply it becomes r times of d theta. And similarly, because of change in phi, which used to be rho of d phi, and rho can be easily converted in form of spherical coordinate system, which is in form of r sin theta, and here goes d phi. So basically you would be using the three different differential length when we would be working on the spherical coordinate system, Now better to understand where the dr is being fetched over here, where the r d theta is being fetched over here, and where the value of r sin theta d phi have come into the picture. You yourself would be able to understand this four differential length, first, second, third and fourth. You yourself would be able to understand. Now the distance from the origin have got increased. If you take the reference of this point, obviously distance of this point and this point was same. Yes, this point and this point was same. But if you go vertically away from this point, so obviously the value of r is keep increasing, and the value of theta as well as phi has been kept constant. We'll see how. But still you can see very well, these are the four differential length which are coming into the picture because of the change in r. So they are nothing but d of r. You can take the reference of either of them. Yes, it's simply coming because of the change in r. Once you are done with this, now why don't we discuss about the r of d theta, which we have already seen. My dear friends, it was a solid cone, and as the solid cone is keep expanding, definitely there would be a certain arc length creation, and you can see very well, these are the arc length creation. First, second, third and fourth. These are the arc length creation, and you yourself would be able to judge. You can see very well, the value of r was constant over this surface, and here again the r was constant over this surface, but here the value of r is greater than the value of r over this surface, and you yourself would be able to understand the creation of the differential length over this surface and this surface. Here it is more, here it is lesser. That means the length creation or the differential length creation because of the change in theta would be directly proportional to the r, and hence it has been taken r of d theta. So what's going to be the r of d theta? Either you can take this, either you can take this, either you can take this, either you can take this. Choice is yours. Let me take this as r of d theta. Agreed, my dear friends? Agreed, no? Now again, I would be discussing about the r sin theta of d phi. D phi, the concept of the d phi has already been visualized in the last class. It was a rotation of a plane taking the reference of z axis. At very beginning, it was kept towards the positive value of x, and it was keep rotating in the anti-clockwise direction, and it was starting from 0 and was going till 2 pi. Yes, no? Diptanshu sir is here. Thank you, sir. Thanks a lot. Our great jam Diptanshu sir is here. Thanks a lot, sir. It's a great compliment for me if you're giving a big hearts, and that to 3. Thanks a lot, sir. Thanks a lot. So could you understand what exactly I wanted to say? So similarly, I had to focus over the r sin theta d phi. So this is nothing but the differential length because of the change in phi. So as I was discussing about the change in phi, what it was, at very beginning I have taken the reference of z axis, and at very beginning I have taken y is equals to constant plane for x greater than equals to of 0. And as I was rotating in the anti-clockwise direction, the value of phi was keep increasing. Here it became 90, here it became 180, here it became 270, and end of the day again it got into the 2 pi. Yes, it got into the 2 pi. The same thing is happening over here. You can see very well this differential length, what you are getting now. How many differential length? The 4 differential length. The first is going to be this, the second is going to be this, third is going to be this, and fourth is going to be this. How they have come into the picture? They have come into the picture because there was a differential variation in phi. But as I have been talking about the differential length, so obviously the length has to get multiplied, and why only r sin theta had got multiplied? Already the reasoning has been given earlier. So you can take the reference of either of them. So tell me, so here you can take the reference of either of them and you will get the exact answer. Yes. So here you will take the reference of this, which would become r sin theta d phi. Either you can take this, either you can take this, either you can take this. Choice is yours. Choice is yours. Agreed? So end of the day, what I would say, lump sum, you guys would have the clear-cut idea where the d of r falls, where the r of d theta falls, where the r sin theta d falls. R sin theta d falls. Yes. And now once you are done with the differential length, so basically now it's right time to move further, and basically we need to talk about the differential surface. Anyways, before going into the detailed analysis of the differential surface, why don't we hop into the differential displacement? And you guys have seen earlier, the use of differential displacement is very, very important, because whenever you get the problem related to the closed line integral, or for the time being vector line integral, by default you are going to use the differential displacement, and that too differential displacement gets changed in case of spherical, cylindrical as well as Cartesian coordinate system. So let me focus over the differential displacement over the spherical coordinate system. We know the differential length in the direction of r is nothing but the dr, so simply it would be written as dr in the direction of r, which is nothing but the unit vector in the direction of r, ar cap plus. Next, here goes the differential length, because of the change in theta, that's nothing but the r theta, and it has come because of the change, and it would be in the direction of a theta cap. It would be in the direction of a theta cap. Yes, and similarly here goes r sin theta, d phi a phi cap, d theta a phi, d phi a phi cap. Yes, d phi a phi cap. Could you agree what I am saying? So in future, whenever you have been using the spherical coordinate system and you have been come across a certain situation where the differential length has to be used, the differential length has to be used in this way. We have seen there is no component gets added or gets multiplied with the dr, so dr would remain bare as a dr get multiplied with the ar cap. So yes. Similarly, if we will talk about the d theta comes along with the r, and that too it is r d theta is in the direction of a theta cap, so here it has been written as a theta cap. And similarly r sin theta d phi a phi cap. Anyways, if we will discuss about the a theta cap and a phi cap, they are the tangent over the differential length. Tangent over the differential length. Once we will go into the detailed analysis, we will go into this part also. Yes, my dear friends. Now, anyways, before going forward, I would like to ask if you guys are having any sort of doubt, you can put it over the live chat. Any sort of doubt, like you could not relate between the Cartesian to spherical coordinate system, differential length which we have taken, the range of r theta phi, differential volume which we are supposed to take, the differential surface which we have taken. If you guys are having any sort of doubt, you can put it over the live chat. I will see, and then we will move forward. Tell me. No doubt? Tell me any sort of doubt you guys are having, you can ask from me. No? Anyways, we'll move forward. Once we are done with the differential length, now it's right time to go forward with the differential surface. No doubt, no? Okay. Now we will move forward with the differential surface. Now we will move forward with the differential surface. Now the differential surface would be the surface because of the change in two differential length. Either they could be the combination of this first two, last two, and even the combination of the first as well as last. Now if you will take the reference of dr as well as d theta, you get a first differential surface. If you want to locate them, you can easily locate them. My dear friends, what is the dr? Dr is the differential length because of the change in r. You can see very well, they are dr. And similarly, if we will talk about the r of d theta, what does it mean of it? R of d theta is nothing but the differential length because of change in a small elemental theta, and you can see very well, this is nothing but the r of d theta. Either you can take this or this. So you yourself would be able to understand. Dr, you can take reference of either of this differential length. R d theta, you can take the reference of either of this differential length. And my dear friends, they are differentially small, or they are infinitely small. What does that mean of it? That means this length is such a small length, almost I can assume this contour is a type of straight line. Yes, not only that, Not only that, if you will assume this is a very infinitely small differential length, again this contour can be taken as a straight line. And put together, the surface which you are forming over here is a type of a rectangle. It's a type of rectangle. And may I know what used to be the area of the rectangle? The area of the rectangle is nothing but the length into breadth, length into height, whatever you can say. So here you can take this as a length, and here you can take this as a width. So differential surface, what we get is simply going to be dr, r can be taken towards the outside, it becomes r dr d theta, which surface I have been talking about. You can see very well the bluish circle I have been talking about, the blue surface. Now would like to ask from each one of you, what would be the differential surface because of the green differential area which has been marked towards downside, green surface area. And similarly, what would be the differential surface which has been marked because of pink surface area? I would like to get the response over the live chat from each one of you. I would request to each one of you, whenever we have the live classes, try to have the two-way communication. Whenever I ask any sort of doubt, any sort of question, try to give the maximum number of responses. My dear friends, why we are taking live classes? Such that the class would be more interactive, and I can ask few of the questions and you can reply over the live chat, and yes, it would be a type of two-way communication. Tell me. Green surface. Now you yourself would be able to understand this green surface is again a type of rectangle. Now again, many of the students would have one doubt, sir, how you are saying it's a rectangle? My dear friends, already it has been said to be differential length. What does it mean by the differential length? The differential length is a infinitely small length which has come because of a change in a certain number, or change in a certain differentially small number. That could be in terms of r, theta or phi, r, theta and phi. So you yourself would be able to understand, if you take this as a rectangle, yes, you can take that as a rectangle, this becomes its length and this becomes its maybe width, and you will be multiplying them together, and once you will be multiplying, definitely the result what you get, the green one is gonna be dr d phi, yes. Obviously, it is nothing but dr d phi, and along with the d phi, already we have seen the r sin theta comes. Similarly, if we'll be talking about the pink surface, you yourself would be able to understand. See, there was a change, or this differential length have come into the picture because of the change in theta. And similarly, this differential length have come into the picture because of the change in phi, which you have already seen earlier. So once you will multiply these two differential lengths because of the change in phi, because of the change in theta, by default you will be getting the result, and the result is going to be simply r square of sin theta d theta d phi. Yes, no, yes, no, yes, my dear friends. So till this moment of point, each and everything must be clear to all of us. Yes. Now instead the differential surface, if I would be discussing about the differential surface with its unit normal, why it's so important, which we have seen in earlier classes. Many of the times we used to calculate how much flux is getting crossed across a certain surface. So not only the surface area matters, even the interaction with the flux density with the surface area also do matter. In that case, I also talk about the face on which the surface has been opened, and there I discuss about the normal over the surface. So may I know what would be the differential surface with the unit normal? See what is happening over here, what is the common methodologies over here, my dear friends. Here you can see very well, there was the change over the r as well as theta. So by default, the unit vector over the r d theta would be in the direction of a phi cap, So what I would be doing? Simply, I would be copying this complete outcome which we have seen. Let me copy this down, bring it to the next working board. So far I was focusing over the differential surface, but now I would be focusing over the differential surface with the unit normal. Differential surface with the unit normal. Surface with the unit normal. unit normal. Yes. Now, if we'll talk about the blue surface, this was its differential surface. Now you had to also draw the unit normal over this differential surface, as the value of r and theta was changing. So definitely the unit vector or the unit normal over this differential surface would be just a minute, let me rub this out, would be in the direction of a phi cap. Here, just a minute, dr d theta we have taken. Okay, here it becomes dr d phi, so it would be in the direction of a theta cap, and here it would be in the direction of ar cap. Yes, ar cap. And one thing I would accept, many of us do not exactly know what does it mean by the ar cap, a theta cap, as well as a phi cap. Probably I would not be going into that detail, where I would be practically understanding the concept of ar cap, a theta cap, a phi cap, how practically they look into the 3D space. Because I know many of the times, if you are not well acquainted with the unit vector in the direction of r, theta and phi, I have seen you find a lot of difficulties once you go into the practical usage of the spherical coordinate system within the thermodynamics as well as within the electromagnetic theory. So I would be keeping each and everything aside. So at very beginning, I have started with the spherical coordinate system. The three numbers we are using for the unique identification of a point in a 3D space, and those number was r, theta, phi. Like in case of Cartesian coordinate system, the number were x, y, z, and similarly in cylindrical coordinate system, the number were rho, phi, z. Once we are done with that, we were talking about the range or the limiting values of rho, r, theta and phi. The r have started from 0 till infinity. Theta was having the range from 0 to pi. Phi was having the range from 0 to 2 pi. Now the next thing comes in mind, sir, what about the phi? How did you decide, my dear friends? The phi is the same phi which we have used in case of cylindrical coordinate system, and there I have seen the range was from 0 to 2 pi. R is nothing but the radius of a sphere, and obviously it would be always a positive value, and that is why I have taken in between 0 to infinity including 0. I have excluded infinity because hypothetically I may be reaching infinity, but practically I may not be able to reach the infinity now. What about the theta? Theta goes from 0 to pi. I have not taken the physical significance of the theta, so probably you may not be able to understand how the theta is moving from 0 to pi. Probably those concepts I would be teaching in the next class. Now what I did, over the same coordinate system, I have superimposed x, y, z, that means the Cartesian coordinate system, then rho, phi and z, that's nothing but the cylindrical coordinate system, and then r, theta and phi, that is nothing but the spherical coordinate system. So now I would say, if you guys are having any sort of doubt, or if you have any sort of relativity problem, that means you are not able to relate how the same problem has been brought into the spherical to the cylindrical to the Cartesian, this particular outcome would be very handy to you. Yes. From here I got to know the relativity between the r, theta, phi and x. That means in future, if you know all of the three numbers along or the attached along with a point over a 3D space, easily you would be able to convert that number or that point in the Cartesian coordinate system, or vice versa. If you know the value of x, y, z of a 3D point or the point over a 3D space, uniquely you can convert into the form of r, theta, phi. Yes, what I did, basically now you would have the three numbers, that's nothing but the r, theta and phi, and differential, if they change from their place, definitely the differential contour would form. Because of r, it's going to be simply dr. Because of theta, it's going to be simply r d theta. And similarly for the d phi, it's going to be rho d phi, where the rho is nothing but r sin theta. So simply I can write it r sin theta d phi. And now you yourself would be able to understand, if all of the differential contours are very small, this complete structure can be taken as cuboid, can be taken as a differential cuboid. Definitely it would have its length, it would have its breadth, it would have its height. So you can take this as a length, this as a maybe width, and this as a height, So now total how many number of edges are getting added? The total 1, 2, 3, 4, 5, 6, 7, 8. 8 number of differential lengths are getting involved. 8 no? Here goes 4, here goes 4, here goes 4, here goes 4. Yes. So what I would be doing over here, you can calculate those differential length have come because of which are the difference values. So I got to know they have come because of r, then theta and then phi. we got to know about the differential length, but more or less whenever we deal with the vector line integration, basically we deal with the differential displacement. So the dr was in the direction of the ar cap, r d theta was a differential contour, and the tangent over the r d theta was a theta cap, and hence it was written as a r d theta a theta cap, and similarly goes with the r sin theta d phi, and the tangent over this differential length is nothing but the a phi cap. Anyways, Krishna Raval was asking one question, my dear friends. So far I did not enter into the volume, so probably this would not be the agenda of today's class, but yes, if you really wants to know about the differential volume, as I have been keep telling, it's a type of a differential cuboid, and if you talk about the volume occupied the differential cuboid, you had to multiply their all three edges, length, width as well as height. Put together the result, what we get into the outcome, dr would get multiplied with the r d theta would get multiplied with the r sin theta d theta. End of the day, the result which we are getting is simply going to be r of sin theta dr d theta d phi. Yes, no. We'll see what are their usage. And at the same time I was discussing about the differential surface with its unit normal. Yes. And many of us would not be appreciating what does it mean by the a phi cap, a theta cap, ar cap. That would be my next class agenda. Like in today's class, I was discussing about the unit vector in the direction of a rho, a theta as well as a phi. In tomorrow's class, I would be discussing about the unit vectors in the direction of a theta, a phi, a z. Can we integrate area to get the differential volume? Can we integrate area to get the differential volume? Not at all, my dear friends, not at all. With the help of area, you can't get the volume. If you really wants to get the volume, you had to. Anyways, that part has been told very clearly in case of engineering mathematics. So I would request to each one of you, if any of us are finding a little bit problem over the calculation of the area as well as volume, how the area can be connected with the volume, those all parts has been clearly explained over the crash course of the engineering mathematics, which is still live in our GATE Academy Global. So definitely you can go through that. Okay then. So this is all which we wanted to cover in today's video. Yes, we would be meeting with the next video. There I would be discussing more interesting point regarding the spherical coordinate system. Once we are done with that, the part of the coordinate system would be over from my side, and once we are done with the part of coordinate system, we will go into the important tools which we used into the vector calculus, which starts from the addition, then multiplication, then divergence, curl, gradient, which are the differential tools, and similarly integration, which starts from the line integration, surface integration, so on and so forth. Okay, then we will meet at the same time tomorrow precisely 9 p.m. and yes, the class will end precisely at 10 p.m. Okay then, bye bye, take care, good night, and yes, do well.